The second part of curve sketching is to look at the derivative. We've already looked at the first derivative. Now we need to look at the second derivative. So remember that from the previous problem, we had that our first derivative, now again, we had a bunch of different formulations of the first derivative. I always like to go right before I set them equal to 0. That is the most simplified version of my life that I'm going to get. So again, right before I set them equal to 0, that's what I'm going to reference in terms of finding the second derivative. So this is my first derivative in its most simplified form. And now I need to answer the questions of concave up and concave down, which of course is related to our second derivative. Now, there are two options to finding the second derivative, and again, it's totally up to you how you want to approach this. One option is that you can go through the quotient rule. Another option, which will make things a little bit easier, and this comes up a lot, we've seen this before, is that if you have a number over a variable, technically you don't need the quotient rule for that. What you can do is you can bring the variable up, and then you'll have parentheses to a number, and you can use the general power rule. So I'm going to take that approach simply because it is a little easier in terms of time. So I have my first derivative here. I'm going to rewrite this, or simplify depending on how you want to think about it, as 52 times 8x minus 6 to the negative 2. So I'm going to bring that power up into the numerator. Again, this is a way that I can completely avoid the quotient rule. I don't have to do a quotient rule. I can simply bring variable quantity up. This positive 2 will come up as a negative 2. And then the help there is that after you do that, then you see that you have parentheses to a number, and anytime we have parentheses to a number, we can use our general power rule. So my second step here will be to use the general power rule, where this is me taking the derivative. I will have the second derivative now, and I bring the 52 times the negative 2 down to get negative 104. Keep the base and subtract 1. Then I will need to multiply that by the derivative of the inner function. So the inner function here being the 8x minus 6. So the derivative of 8x will simply be 8. And then the derivative of the negative 6 is a standalone constant, so that goes to 0. So my inner function derivative is 8. Now, as we discussed, usually these bookends will combine together. So the quantity in the middle, that parentheses to a power, cannot combine, but usually the front and the back, you can multiply those two together. So I can take the negative 104 times the 8, and that gives me a big number. That gives me negative 832, 8x minus 6 to the negative 3 as my second derivative. Now, if I'm going to go through the test for concavity, or the concavity test, what I need to do is I need to first set my second derivative equal to 0 or does not exist. That means that I want one fraction. So just like with the first derivative test, for the concavity test, I need to have a single fraction. So here, when you're looking at your second derivative, you'll notice you have this negative exponent. And obviously we don't want to have that negative exponent because we want this one single fraction. So we are going to move our negative exponents as soon as we possibly can. So that's going to give us that our second derivative looks like negative 832 over, and then 8x minus 6 to the third power. And then just like we did before, set the numerator equal to 0 to find where the second derivative is equal to 0, and then denominator does not exist, or equal to 0 will give us where the second derivative does not exist. So that gives us negative 832 equals 0, and then this 8x minus 6 to the third equal to 0. Again, there's no x here to solve for, so completely ignore the negative 832. Here we can undo the cube power by taking the cube root of both sides. You can also just think about it as I'm going to set 8x minus 6 equal to 0. So ultimately, I have 8x minus 6 equal to 0, and then add 6 to both sides, and then divide by 8. So that gives us 3/4. And it is somewhat of a coincidence that this 3/4 number also pops up with the concavity test. That is not to be always expected. So it's a little bit of a coincidence there. Now, with this 3/4, we are then going to draw our derivative number line. However, now we are plugging into the second derivative. So the information that we're going to get is going to be different because it's the second derivative. Now, just like before, look right before you set them equal to 0. That is most likely your most simplified form of the derivative. So what you'll have is you'll have f double prime equals negative 832 over 8x minus 6 to the third power. We have our 3/4 number, and then we simply need to plug in a number to the left of 3/4. So maybe I decide to plug in 0. It's really important to not put the number 0 down because 0 could be picked, somebody else could pick -1 or what have you. So don't get into a habit of putting the numbers on the number line. Just kind of put them below because 0 is not going to impact our number line. It's just going to tell us the sign. So again, try to not put it on the number line. All right, so this gives us negative 832 over 8 times 0 minus 6 to the third power. So in the numerator, I have a negative. In the denominator, we're simply going to have negative 6 to the third power. And you can type this in on your calculator, but negative raised to an odd power will give us a negative. So we have a negative over a negative, and that simply gives us a positive. Now, this positive is telling us different information because we're looking at the second derivative. That positive will tell us that we are concave up on the first interval. So it's not telling us increasing, decreasing. It's now telling us about concavity because we're working with that second derivative. And then we'll test a number to the right of 3/4. So maybe I plug in 1, and again, plugging it into the second derivative. That gives us a negative in the numerator. In the denominator, I simply have 8 minus 6 to the third power. So I have 2 raised to the third power. That gives us a negative over a positive. That mix of signs means that we have a negative overall. Now, that negative, because we're talking about the second derivative, is going to tell us that it's concave down on that interval. So when you're working on the homework software, you will simply say that it's concave up. Always make sure you read that very carefully to make sure you're reporting the correct answer. Concave up on negative infinity to 3/4. Remember, these intervals are always with parentheses. And then concave down from 3/4 to infinity. Now, it's tempting to want to say that there's an inflection point at 3/4. So let's try to take a minute and think about what that would look like. Remember, an inflection point is an x comma y coordinate. So if I try to find the inflection point, anytime we are working with a point, it is an x comma y, and with that point, we need to plug into the original function. So we're kind of looking at this and we're saying there's a change in signs in concavity, therefore this is going to be an inflection point. But when we go to our original function, which was such a long time ago, but our original function was this 2x minus 8 over 8x minus 6. So I'll write that here, 2x minus 8 over 8x minus 6. Okay, so that's my original function. I'm thinking that this 3/4 is an inflection point for us. So I have 3/4, and then I'm going to plug in the 3/4 here. Okay, so what that's going to give us is it's going to give us 6. So I'm going to multiply straight across here. So it's going to be 6 over 2 minus 8. And then in the denominator, multiplying straight across here, I have 24 over 4 minus 6. So that simplifies further into 3 minus 8 over 24 over 4 gives us a 6 minus, not 3, sorry you guys, I did this too quickly. So we have 2 times 3, that's going to give us a 6, but then there's going to be a 4 in the denominator. So that's going to give us 3 halves minus 8. So again, I just too quickly reported that out. So it's going to be 2 times 3 to get 6 over 4, and then the minus 8. In the denominator, we're going to have 24 divided by 4, which is going to give us 6, minus 6. Now, right here, you don't even have to worry about what 3 halves minus 8 is because you have a number over 0 in the denominator. And remember, what is a number over 0? That is undefined. So what you're finding here when you go and try to find your inflection point, that the point would be 3/4, comma, undefined. Now, that makes absolutely no sense to say that you have a point on your graph that is undefined, right? That does not make sense. So for that reason, we are going to say that there is no inflection point. Now, you might be like, well, what's going on here? What's going on here is twofold. First of all, you'll remember that over when we were talking about the first derivative, the 3/4 was actually a domain restriction. And that domain restriction at 3/4 is going to prevent the first derivative and the second derivative from being defined at the 3/4. So you could have recognized it just based off of the domain restriction. A lot of students kind of fly right by that domain restriction though. And so if you do, that is okay in a sense, because when you plug in the 3/4, you will immediately see that it's undefined. And that will be kind of like hitting you right there in the face saying, okay, this is not going to work for us. It is in fact undefined. And so again, when we get that undefined, anytime you get that the point is undefined, you would have to say that there is no inflection point.